Now we will see orthographic projections. Orthographic projections. Now, before going to orthographic projections, first see what are the different types of projections available in engineering drawing. To represent a solid body on the drawing sheet, around 4 types of projections we used. First type of projection is orthographic projection. Orthographic projection. Second type of projection is isometric projection. Second type is isometric projection. Third one is oblique projection. Oblique projection. And fourth one is perspective projection. Perspective projection. Now see, here to represent the solid object, these 4 types of projections are available in engineering drawing. Now, what is an isometric projection? First we will see. In the isometric projection, here isometric, that means equal measurements or equal reduction of length of the sides as well as angles. It is considered in isometric projection. That means a cube, the solid diagonal is perpendicular to the vertical plane. When we see that object, then the front view, side view and top view, these 3 views we can see in one object. Okay, then such type of projection is called as isometric projection. The main advantage of isometric projection is we can imagine the shape of the respective object very easily. That is the main advantage of isometric projection. But in the isometric projection, the angles will different and non-isometric lines, those lengths will be different. But we can imagine the respective item or respective solid body very easily by seeing front view, top view and side view. Now come to oblique projection. And in the oblique projection, one face of the object is enlarged and other faces are decreased, or other than the 90, other than non-proportionality, whatever be the face details are required, we can enlarge that face. Other faces are decreased. In such type of projection is called as oblique projection. Mainly oblique projections are very much useful in electronic applications. In the case of electronics, many smaller devices or smaller components on one face. So that if we reduce all the faces to same scale or all the angles to same scale, the smaller items details we may not observe. In such cases, we need to enlarge one face and we need to reduce the other faces. Okay, that is the advantage of oblique projection. The fourth one is perspective projection. In the perspective projection, that means as we observed with our naked eye, the object is drawn on the drawing sheet, we can say that is the perspective projection. That means if we see lengthy train from the side, front face is enlarged, and when we see the last bogie or last compartment, the size of the compartment gradually reduced. And same thing we can see in the case of electrical wires also. If you see the electrical wires, if you see for long distances, the wires are merged, seems to be merged at one point. Okay, that means how we are observing the actual object, if those are drawn actually on the drawing sheet, we can say that type of projection is perspective projection. Perspective projections mainly used in architectural drawings. So suppose if you see the architectural drawing of apartment, those apartments mainly drawn in perspective projections only. Okay, that means here I will summarize isometric projections, front view, top view, left side view or right side view. We can see in the one drawing and we can imagine the shape of the object very easily. And in the case of oblique projection, when the details at one face are very small or miscellaneous or minute, then we need to draw the oblique projection by enlarging the face which have smaller details. Okay, next, perspective projection. It is used when we want to draw the drawing what we observed with our naked eye, that is the perspective projection. Now come to orthographic projection. What is the advantage of orthographic projection? Why it is required? Among all these four, these three are for the purpose of imagination, for the purpose of giving details, for the purpose of aesthetic sense, these are there. But to measure the exact dimensions from the drawing, as well as to draw the exact details very easily in the front view, top view, left side view and right side view. Okay, likewise, these orthographic projections are utilized. Now we will see what is orthographic projection. Now, to understand the orthographic projections, first we need to understand principal planes. Principal planes. What are principal planes and how those are? See, here you can see the vertical plane and horizontal plane. Vertical plane and horizontal plane you can see here. Right. Now, this is the vertical plane and this is the horizontal plane. Okay, these planes are called as the principal planes. Suppose an object, if it is in this space like this, how we can specify its position? It is quite difficult with reference to floor or with reference to wall or with reference to the board. Likewise, we need to represent the position of an object. But when we place these reference planes like this, the entire space is divided into 4 quadrants. Okay, and we can say this one is the first quadrant, this one is the second quadrant, this one is the third quadrant, and this one is the fourth quadrant. Okay, 4 quadrants. Now, if an object here, now then we can say this object is above the horizontal plane and in front of the vertical plane. How it is in front? Here, with respect to the observer position, we need to say. That means the observer need to be here. When the observer need to be here, then the object, if you put like this, then it is above the horizontal plane and in front of the vertical plane. Okay? Now, if you consider like this, now I am the observer, here the object. I can say this object is above the horizontal plane and behind the vertical plane, right? Now, the object is here below the horizontal plane and behind the vertical plane. Now, the object is below the horizontal plane and in front of the vertical plane. That means with respect to HP and VP, the position of object we will say very easily, right? And when we consider an object here, and if we draw the front and top views, that is called as a first angle projection. And if we consider object here, and when we draw the front and top views, it is called as second angle projection. When we consider the object here, and when we draw the front and top views, it is a third angle projection. And when we consider the object here, and if we draw the projections, it is called as a fourth angle projection. Okay. Now, what are the other observations we can do? Okay. And here, the term ortho that indicates 90 degrees. When it is at 90 degrees, what are at 90 degrees we need to see? Suppose observer here, and here is the principal planes or vertical and horizontal plane, and here is the object. Now I imagine all the rays which are emitted from my eye are parallel to each other. That means I consider that, or I assumed that I am at infinity distance, observer at infinity distance, then the rays which are emitted from the eye of the observer are parallel to each other. After that, those rays are passing through the contours of the object. After that, it will pierce the respective vertical plane. That means whatever be the shape we observed, okay, that shape it is obtained here. Okay, and the rays which are reach the vertical plane, those are perpendicular to this projection plane. Okay, this is projection plane, this is object, and here is the observer. Observer at the infinity distance, and projection plane behind the object, and object, through the object all the projectors are passing, and those are parallel to each other. They reach the projection plane at 90 degrees. Now, if you go for the top view, the observer will see the object in this direction. Okay, when he see the object in this direction, all the rays which are emitted from the eye parallel to each other and passing through the outer profile of the object. After that, it will reach the horizontal plane, and the projection or the shape is obtained here. Now, we cannot draw this VP and HP in this position on the drawing sheet. Drawing sheet is a 2D. Okay. Now, here is the front view. Here is the top view. To draw the vertical and to draw the front view and top view in the first angle projection, now I will turn this like this. After that, I will rotate the horizontal plane like this. Now you see front view here and top view here, and the intersection of vertical plane and horizontal plane is a line. We can call this line is a reference line. Okay. Likewise, we can draw the front view and top view. We will see some more observations here. Suppose an object is above the horizontal plane 10 mm and in front of the vertical plane 15 mm. That means if we see the front view, above the horizontal plane, this distance is visible in the front view. That means after the rotation of horizontal plane, we need to consider 15 mm distance from the reference line. Okay, right. Next one. If we see the top view, it is in front of VP 10 mm. That means that 10 mm distance is visible when in the top view, true length is visible. This distance we need to maintain. After the rotation from the reference line, we need to maintain that 10 mm distance. And another thing, the projectors of the front view, suppose if you consider this face, here the projector, okay, and the face projector in the top view, after the rotation of the plane, both are collinear. That means they are lying on the same line. Okay, here the student did mistake many times. Sometimes they want to draw the front view, top view and side view. Front view at one place, top view here nearby the front view. After that side view, they draw like that. It is not correct. Okay, because front view, top view, side view, respective to the reference line, we need to draw. Okay, now here we observe the first angle. Okay, we will summarize the result what we get here. In the first angle projection, what is the position of the object? Position of the object above the HP, and in front of VP. Okay, this is the position. It is given for the first angle projection. Second one, in the first angle projection, front view obtained on VP and above the reference line. Okay, next come to top view. Top view obtained on horizontal plane and below the reference line. Okay, and the projectors of the front view and the top view are collinear. Okay, this is true for all coordinates or for all angles of projections. Okay, projectors of front view and top view are collinear for same point. Okay, that means one point if we consider in the front view, and if we project in the top view, the projector is the collinear, right? These things we need to remember. And at the same time, the front view it is obtained on the VP and above the reference line. That means above the HP, whatever be the distance, that distance is visible in the front view. Okay, now come to top view. It is obtained on the HP and below the reference line. That means whatever be the distance from VP, that true distance is visible in the top view. Okay, these things we need to remember for the first angle projection. Now we come for the second angle projection. Now we will see. What is the position of object? Position of object is above the HP, and behind the VP. Now we will observe the respective position. See the object here. That means the object is behind the vertical plane. Okay, and the vertical plane is a transparent plane. That is the reason in the front view the observer can see the object. Okay, now the front view is obtained on the vertical plane like this, right? Now, to see the top view, observer at the top, and the top view is obtained in the horizontal plane. And here also the projectors of front view and top view are collinear. Right? Now, we assume the rotation of a horizontal plane. Now, the horizontal plane is rotated like this. Now, what happened? Front view is here and also top view also overlaps on the front view. Okay, that means both front and top views are above the reference line. Okay, therefore one overlap the other, then we cannot observe the exact dimensions or exact shape of the respective views. That is the reason the second angle projection nowhere it is utilized. However, to understand the concept, we need to learn the second angle projection. Right, now we will summarize the respective points. Position of the object is above horizontal plane and behind the VP. Next, front view. Front view. Front view obtained on VP. Okay, and above the reference line. Okay, now come to top view. Top view obtained on the HP, and it is also after the rotation of a horizontal plane above the reference line. Above the reference line. Okay. Now, both front view and top view after the rotation above the reference lines. Therefore, overlapping is there. Overlapping of front view and top view. It is present. Okay. Now, we will see the third angle projection.